Hello, welcome to everyone in this video. In this video, I want to discuss about the question which asked in the paper 3 or CC3 paper of second semester for University of Calcutta in 2021. We already covered up the question paper 2019 of Calcutta University of CC3 and CC4 paper. If you want, you can go through the description link or given there. And also we cover up the questions asked in West Bengal State University. You can also go through the description box, link are given there. In this video, I want to discuss question which asked in the Calcutta University second semester of physics honors 2021. So let's start with the question. Look at this question at a glance. You need to answer question number 1 and any 4 on the rest. So in this question number 1, there is A, B, C, D, E, F, G. I request all of you, you try to solve this question that is A, B, C, D, E, F, G. You try to solve this question at yourself. After that, you go through the video to watch the solution of these questions. So this is 1 and this is question number 2, that is 2A, B and C. Then question number 3, which have A, B, C, whose have the 4 parts. And then go to the question number 4, whose have question A, B. And then question number 5, which has A, B, C. And question number 6 have A, B, C. And then question number 7 has A, B, C. And where there is a or for this old syllabus, that is 18, 19, whose have a or of this question number 6. I think you clear about the question format of this paper, CC3 paper of year 2021 of the physics honors second semester of University of Calcutta, right? So I request all of you try to solve this question at yourself. After that, if there is any problem to solve the question, you can go through the video to watch the solution of this question, right? So let's start with the solution. You can see the first question says, consider a sphere of radius r where the origin surrounded by n charges at j star is ej. So there is n charge distribution throughout this region where there is a sphere radius r, where rj is less than r, that means the charge all are enclosed within the sphere. So express the total charge density of the sphere in terms of delta function and evaluate the total flux density. So the charge distribution are since discrete, so we can say this is the nth charge or ith charge is will be ej delta q r minus r q. This is the 3-dimension delta function. Now if you wants to find out the total electric flux, this is nothing but E dot ds, which is E enclosed by epsilon naught. So you need to find out the total charge enclosed. This is nothing but the integration of these things, and this is nothing but the summation of these discrete charges. So this will be the total charge, and this is nothing but the satisfy the Gauss law. Next question. Find the general solution of Laplace equation in spherical coordinate for this case where the potential V depends on R only. Where the potential depends on R only. You know the Laplace equation will be grad square V equals to 0, and in the spherical coordinate system there will be 1 by r square del del r square del V del r. And since V is depends only R, that's why we return this r parameter, r variance, and we neglect the theta and phi part because this will be 0 since V is depends only r. So you can write this r square equals to multiply with this 0, it will gives you 0, and del del change into ddr because this V is only function of r. So we can see this r square del V dr equals to this. So after that, just separate out, and if you integrate, you will be get these two things. And this constant can be find out by this condition that r tends to infinity, then the potential must be 0. So V is nothing but minus C by R. So this is the general solution of the potential which satisfy the Laplace equation and spherical coordinate system where this V is only variance or that depends only R, which is also matches, right? Go to the next one. Next question says a dielectric medium is said to be simple if it is homogeneous, isotropic and linear. Explain the statement briefly and then find the relation between susceptibility and permittivity for such material. So you know the dielectric medium with the homogeneous mean the all the property are same throughout this distribution, throughout this medium, in this throughout medium all the property will be the same. This is the isotropic, sorry, homogeneous. Isotropic means the change in property in all direction will be the same. If there is the change any property in some direction, then in the another direction this also be the same. And the linear, that is the linearly polarized of the electric field, that is the polarization depend on the linear relation with this electric field, that is the polarization depend only linearly with the electric field. So these are the three condition, and this simplify that is the this dielectric medium will be the simple medium, because we can write this polarization as a simple relation with this electric field, applied electric field. Okay, so E0 is the applied external electric field and P is the polarization. E0 is the applied external electric field and P is the polarization, right? Sorry. So the total electric field within this material, you can see this E equals to epsilon naught E0 minus P. This minus arises because this is a dielectric medium. Dielectric medium is the opposite to this the electric field, like that. Or you can say actually we do not consider this minus, we take plus here. Within this polarization this will be the minus inherent. If this material will be the opposite direction, this will be we does not consider here. We take this plus because within this region there will be the negative inbuilt. Okay, so this total electric field within this medium, this is epsilon naught E and P is the polarization. This is effect of external electric field and this polarization field. This will be same direction or opposite direction, whatever the, in general you can write down this relation. Okay, so this is the relation between the susceptibility and the permittivity. Susceptibility is chi E, E for electrical, and epsilon is the permittivity. Clear? Go to the next one. For any query, any suggestion, you must comment in the comment box. Go to the next one. Find the magnetic field at a distance s due to infinitely long straight filament of current I. So this is the current filament of current I, and from the distance from this where you need to find out magnetic field at the distance s. Okay, so you need to consider the current entering the conductor, infinite carrying current. We wants to find out the magnetic field at distance s. So from this conductor during a circular loop, you can see by the Ampere's loop, B dot dl equals to mu naught I enclosed, and here the I equals to I enclosed equals to I, and this is BDL. So finally we got the mu naught I by 2 pi s, where s is the distance from this axis. Okay, from this axis. Next one. Next one says, I think clear. No. Next one says, so that the Faraday's law of induction equivalent to this relation. So Faraday's law is says nothing but the EMF induced within a closed loop will be like that. Change in the flux induced within this chain will be like that. So epsilon proportional to minus d phi dt. So that is epsilon equals to minus d phi dt. So E dot dl equals to minus dv dt. Phi nothing but b dot a. So in integral form v dot ds. So this can be written in the like from, so curl of E equals to minus del v del t. Okay, so just look at this solution, you can understand easily. Next one. Derive an expression for the speed of light in vacuum from the Maxwell equation. So you need to write down the Maxwell equation. Divergence equals to 0, divergence is equals to 0, curl of E equals to minus del H del t, and curl of H equals to epsilon naught del E del t. So taking the curl of equation 3, you will be get this equation, and putting this value using equation 4. Finally you get this equation, and this is nothing but 1 by c square, which is the differential equation of any simple harmonic motion or any wave equation. So this is this velocity, which is 1 by epsilon naught mu naught. Simple. Next one. Lenge's law is consequence of law of conservation explained. So Lenge's law, you can know that is the Lenge's law is in the direction of the induced EMF, in such direction it can oppose the cause. That means if you consider when this north pole is come towards here, and here the current flow in like that, this is along the same direction, then without any work done you get the current EMF induced within this material. This is does not matches with the conservation of energy, but in direction in such a direction that it can oppose to this magnet. That's mean if you wants to go towards this loop, then you need to work, and this work actually converted into this electromagnetic EMF. Clear? Next one. These are written here in this language. You look at this language, and to understand, if there is any problem to understand, you need comment in the comment box. Next one. Write the expression of potential energy of a dipole and dipole moment P placed in an external electric field E. Hence write down hence so that the force on the dipole due to electric field is given by like that. So you need to find write down the potential energy with terms of dipole moment and the external electric field. You know the potential energy in the dipole moment in the external electric field V dot E. Now you need to find out the force. You know force is nothing but minus grad U, and U is minus P dot E. So taking just gradient of this by using the vector identity, you know this vector identity have the four terms, and curl of E you know 0, curl of P is 0, because this P does not depend on the coordinate curl. Here you can write down this P, these and these two things 0, because this P depends only source coordinate, depend only source coordinate, but here this is the field coordinate. That's why these two are 0. Okay, that's why these two are 0. After getting this 0, you will be get only this term. Okay, so I think clear about this solution. Go to the next one. Define electric displacement vector in dielectric medium. Show that curl of the displacement vector is not 0 in general, even in electrostatic case. So displacement vector is nothing but the summation of these two terms, that is epsilon naught E plus P, which also known as this E. Okay, so where this is permittivity in free space is the electric field, and P is the polarization within this medium. So now taking the curl in the both side, if you take this curl in the both side, you will be get grad of D equals to like that. So after curl is this two term, curl of E equals to 0, but curl of D will be get curl of P. Curl of E equals to 0 for electrostatic case. So in case also in case of non-electrostatic case, this is not equal to 0, that's okay. But in case of electrostatic field, this is also not equals to 0, because curl of P is not 0. Next one. So that electric potential at any arbitrary point r due to electric dipole placed at r prime of dipole moment P can be written as like that. So you need to find prove that this phi, that is the uh, potential, can be written as like that. Okay, assume that this dipole is small compared to this. So the dipole moment due to so the potential due to dipole is like that. So just imagine this figure, and you can write down this electrical potential very easily. After that, just wants to calculate this one. This root over like that is nothing but dot product with to the power half, and taking 1 by r as a common, and this half will be in the upper side will be minus half, and expand by binary theorem, binomial theorem, expand by binomial theorem, you will be get this expression. Putting this value in this phi of r, will be easily find out this phi of r, and you know ql is p. So this phi can be written as like that. Now you know that grads of 1 by nothing but r vector by rq, and grad of 1 by r equals to r vector by rq. Oh sorry, there is a minus grad prime 1 by r equals to, okay. So the phi will be written as like that, because this is nothing but the grad prime 1 by r, or you can terms in grad, this is 1 by r. So phi equals to p dot grad phi 0, where phi 0 is the 1 by 4 pi epsilon naught is the potential for the unit point charge. Okay, I think there is any mistake. No, grad grad phi 0, there is will be the r. right? There is a r in this missing r, 1 by 4 pi epsilon. Potential a unit point charge, so this will be a r. Okay, so there will be a r here. Okay, I think clear. Next one, calculate consider a point charge at origin starting from this equation. This is the electric field due to point charge. Prove that curl of E equals to 0. You know E equals to like that, and this r cap is nothing but r vector by r. So this is r vector by r cube. So if you take curl of this vector, curl of r vector by r cube, so taking the vector identity, that is curl of 1 by r cube cross r vector, and this is 1 by r cube curl of r, this will be the 0. And if you derivative, this is nothing but simple derivative with the r cap, so simple derivative minus 3 by r to the 4, and r cap is r vector by r, so r cross r is 0 and curl of r is 0, so curl of E equals to 0. Clear? Next one, consider the electric field in this region E equals to K RQ R cap. This is our given. Calculate the amount of charge contained within the spherical shell of radius A at the origin. So E equals to K RQ R vector. So this is K R square R vectors. From the dielectric equation of Gauss law, divergence E equals to rho by epsilon naught. So finally rho equals to epsilon naught divergence E. Okay. So put this value of E and just taking this divergence and the vector using this vector identity, uh, divergence of phi equals to phi divergence A and grad phi dot A. So it's simply using this relation, and this is nothing but simple derivative with respect to r cap. So this is 2r, r cap is r vector by r, and this is 3. So putting this value you can easily find out this. So this is the charge density. So the total charge within this sphere equals to rho dV. Putting this value of rho, and dV is 4 pi r square dr within this radius 0 to a. So finally you get this value of q, that is the total charge enclosed within this sphere. Next one, suppose a charge q is distributed within a sphere of radius a in such a way that the charge density rho r at a distance r from the center of the sphere is like that. So rho r equals to k r minus r, 0 for 0 less than r and r greater than r. Determine the constant k in terms of q and r. Okay, so you need to find out the value of constant value k in terms of q and r. A charge q is distributed within a sphere of radius r. This is the distribution. Hence, q is total charge equal to rho dV. So within this region, outside is 0. So within this region, put this value, and integrating this integration, carefully you do integration, you can easily find out the value of k. Okay, I can say that you can do this integration very easily. Next one, calculate the electric field at any point inside the sphere. So you need to find out the electric field inside the sphere. So using the Gauss theorem, E dot D equal to Q by epsilon naught. So here the rho dV within this region. So here the integration will be up to small r, right? So since this charge enclosed within that sphere, you need to consider. So this integration limit will be 0 to small r. So finally we will be got this electric field will be like that. Okay, and third one was the find the value of r for which the field will be maximum. So at maximum field, you know that the first derivative must be 0. So the first derivative of the electric field with respect to r must be 0. So taking the first derivative with respect to r of this equation, you can finally got the r equals to 2/3 r. That mean at this region, at this radius, this electric field will be maximum within that region. And fourth one, what is the value of maximum field? So just put this value of r as a 2/3 capital R, you will be get easily the maximum electric field. Put this expression, that is r equals to 2/3 capital R in this electric field equation. You can find out easily this maximum electric field within this region. Okay, next one, a sphere of radius capital R carries polarization. This is the polarization which depends on R only. You can see here. Calculate the bound charge sigma b and the volume. This is actually surface bound charge. This is the volume bound charge. And you know the volume bound charge is nothing but minus grad of p. So taking this grad of p, this is this only R variation. That's why we taking this only R variation here. So just taking this derivative. This is nothing but R square, and PR is nothing but R and K. So this is r cube, so the derivative will be 3r square. So r square cancel out, minus 3k. And the surface charge density will be p dot n cap. Here the n cap will be r cap, so only the r cap will be here. At the surface r equals to capital R, so this will be minus is capital plus kr. Find the field inside and outside the sphere. In case of the inside, the Gauss theorem says that E dot D equals to 1 by 4 pi epsilon naught Q enclosed within this region. So this is rho dB, and the limit will be r equals to 0 to small r. Okay. So this is the electric field within this region. And for electric field with for the outside region, the limit will be the for in case of outside, this surface charge density also must be considered. Before case we consider only volume charge density, because this region is inside to this surface. But in the outside case, when the r greater than r outside case, you need to consider two charges, that is the charge within the sphere and the charge on the surface. That's why there is two integration, that is within the sphere 0 to r, this is rho and this is dV, and sigma is the surface charge density, and this area will be like that. Okay, so if you integrating, this is 4 third pi r cube, and this is nothing but 4 pi r square. You can see here this third cancel out, this is 4 pi k r cube, and this is also 4 pi k r cube. This is minus, this is plus, that's why this will be 0. Okay, so the electric field outside this region must be 0. And next one, sorry, okay, and next one, a point charge q is placed at a distance d from the center grounded conducting of sphere a. Okay, so there is a sphere, grounded conducting sphere whose radius is a, and there is a point charge q at a distance small d. So calculate the radial component of the electric field at a distance r from the center where r is greater than a. Okay, so from the electrical image problem, we will already discuss during the solution of the electricity and magnetism by Vasudev Ghosh, and electrodynamics by DJ Griffith. So the during this solution we already discussed about the image problem. If you know, that's well, that's okay, but if you don't know about these things, you can go to the description box, link are given there. Okay, so this is the induced charge within this distance square by d. Okay, so the potential will be at any point can be written as like that. This will be the potential at the any point, right? Where ap is that distance and bp will be the that distance. So put this value and ap and bp in terms of the vector. You can easily say this is r square plus d square to r d cos theta, and this is d prime, so on. So the electric field is nothing but minus grad phi. So taking the derivative with respect to r, because okay, so radial component, so you need to derivative with respect to r. Now the induced charge density, okay, so after calculating you will be get this expression. If you wants to put this value of q prime and d prime, which are the like that, q prime equals to minus qa by d, and d prime is the a square by d. If you put this value, you will be easily find out this expression. Okay, and in case of the surface charge density, you will be use this formula, that is minus epsilon naught del phi del r at r equals to a, which is come from the uh, boundary condition of this dielectric material. So taking the derivative and put this value r equals to r, you will be finally got this surface charge density. Next one, starting from the Biot-Savart law, derive the Ampere circuital law. This is the Biot-Savart law. You know, mu naught by 4 pi j cross r cube dv, and you know this is derivation of 1 by r equals to minus r by r cube. So taking this as a written like that. So if you take this, will be curl of r minus curl of j by r. Actually, if you take this one equals to this plus this, from where you can easily find out like that. Okay, which b equals to, which becomes this b equals to like that. So curl of b equals to curl of this. So if you take this curl of this one, it will be into two format, called like that. Sorry. And you know this curl of one, grad of 1 by equals to grad prime 1 by r. So using this condition, and this that is dirac delta function, you can write down this expression very easily. So curl of B equals to, you finally got this mu naught J. Here the consider that at the infinity, that J must be 0. Okay, tends to infinity, J must be equals to 0. So curl of B equals to mu naught J. And if you take the integration, closed loop integration, you will get the Ampere's law. So by this rule, you can easily find out the Ampere's law from the bicycle law. Okay, next one. A steady current I flow down a long cylindrical wire of radius A. This is the cylindrical of radius A. This will be the current flow down. Find the magnetic field both the inside and outside if the current is uniformly distributed over the surface of the wire. If the current is over the surface, so at R less than A inside, that is no current enclosed within the inside, because the current is flow through the surface, right? So by Ampere's law, you can say B dot D equal to 0. So the B inside the electric field, inside this region, magnetic field will be 0. For outside, that is in that region, the current will be considered I. So this will be B equals to mu naught I by 2 pi r using the Ampere's law. If the current distributed in the such a way that the current density J is proportional to S. So J is proportional to S. S is the distance from the axis. So J equal to Kx. So in the same manner, you will be find out the value of J here, because this is not inside. Some current density will be appear here. So putting this value and integrating, you can easily find out the B in. So this output potential will be like that, and this is the input potential. So this will be the output magnetic field, not potential, sorry. Output magnetic field and the input magnetic field. Next one. A long straight conductor carrying current I and determine the force per unit length of the conductor when they produce uniform magnetic field. So a straight current, this is the magnetic field, and the force per unit conductor equal to F I dl. So F I B sine theta, and L is the force per unit length. So the force per unit length will be divided. This F will be divided by L. So this will be the RB IB sine theta. Next one. So that the equivalent inductance of two coil of self inductance L1 L2 mutual inductance parallel, connected in parallel. So these two are parallel self inductance inductor. So the EMF produced in the distribution will be EMF equals to minus d phi dt at d phi to dt. So the Laplace equation from this figure, you can easily find out this is the Laplace equation for this one and this one also in the two path. So solving this above equation, you get this d1 dt equals to like that, di2 dt equals to like that, di by dt equals to like that. So finally you got this I equals to I1 plus I2, and finally you got this is got this relation. Okay. So after solving this, you will be get the L effective will be like that. In a similar pattern, if you take the connector in opposite direction, the one pair of like that, so finally you get the L effective. Okay. Next one, a coil of self inductance L equals to like that, and the series of self inductance or like that. The effective inductance of the combination will be 17 mini henry. So you can see here that the 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 effective E equals to less, so this must be in anti-parallel, and this can be held by this sorry, using this KVL at this another region anti-parallel. If you take anti-parallel, the same manner you will be get this one, and this will be must be taken as an amplifier connector in the parallel and in the anti-parallel. Sorry. So we will take this anti-parallel because this L effective is lower than the L1 and L2. That's why we take this one. Number so C, we says the consider LC's combination of series resistance R. Calculate the voltage output of these things. So you need to find out the voltage output across the LC combination. So here V is the written in this. So in this V equals to like that. So independence of the circuit will be nothing but for the R equals to J omega L, and this is will be the 1 by J omega C. The impedance due to capacitor will be 1 by J omega C, and impedance due to L equals to J omega L, and this is the R. So the impedance will be like that, and the corresponding potential will be like that. Okay, next one. Displacement current. What do you mean by displacement current? The displacement current which is produce magnetic field but which does not link with the motion of the free electrons. It none of the other property of the current. Okay, so it can have a finite value even in a vacuum. It has a constant value in this vacuum. These are the property of the same displacement current. You need to show that the Maxwell equation constitutes the equation of continuity. So written down the Maxwell equation, and if you take this curl of this equation, you will be get this equation, and this is nothing but the solution for the solution, and this is the solution for this is the solution of this. Okay, so this is the equation of continuity. Next one. Consider plane wave solution of electromagnetic wave in free space so that the wave is transversal in nature. So this is the Laplace equation, and this is the curl of this, and substituting this. This is nothing but the natural wave equations where this will be the speed. So from comparing, you will be get this speed. But the consider wave the electromagnetic wave in space. Okay. So in general, gets psi equals to this Laplace general equation where the solution will be E and D like that. And from equation 1, that was the divergence E equals to 0, divergence D equals to 0, and divergence B equals to 0. So using this relation, divergence D equals to 0 means divergence E 0, and divergence A is equals to 0 means divergence B equals to 0. So using this relation, you can find out that is the k dot E equals to 0 and k dot H must be 0. You just taking this derivative differentiate with respect to R, because this is that is the divergence, right? This is the divergence, so divergence can be find out by this relation. If divergence 0, that means E and B must be perpendicular to each other. Next one. A 100 watt sorry a 100 watt 20-volt bulb, there is connected in AC main switch with voltage 400, frequency 50 Hz. What capacitor must be added in the series combination such that you often glow? So the resistance of this lamp will be like that, and impedance of the circuit will be nothing but these two are R, and this impedance due to capacitance will be 1 by omega C. So this is the impedance, that is the against that is the impedance within this circuit. Okay, so the power is nothing but current square R. So current is nothing but total voltage by total resistance. So you will be find out this relation after calculating. You just follow up this calculation. After calculating, you can easily find out the value of the capacitance. Next one. Consider the circuit which principle of superposition uh, find the potential drop across the 5 kilo ohm resistance. Okay, so by superposition theorem we can take a single source at a time. So if you just this one replaced by an is internal impedance, that means this is open. So the potential across this one nothing but this current by resistance to current is nothing but voltage by total resistance flow through this circuit. So this current into this resistance, that is 9 volt, and the replace the voltage source by its zero internal resistance. In the second case, the voltage source replaced by zero internal resistance. So this 3 and 2 will be 5, So you can see this 5, so this current is equally distributed. So 6 required distributed 3 and 3. So the current flow through this 5 kilo ohm is 3 ampere. So the voltage will be these 3 and 5, that is 15. Hence by superposition theorem we can say the voltage across this one nothing but the V1 and V2. V1 was the due to this source and for V2 will be this current source. Okay. So this will be the total voltage across this one. Okay. So that's it. I think I cover up the all the question 7 8 and this is sorry 6. Okay, 6 7 up to 6 7 we already covered total question. Okay. So that's it for today. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details. You can connect with me with this Telegram channel to get the notification of video and also get the PDF copy of this lecture. If you want to download the PDF copy of this lecture, you can go to this Telegram channel and join with me and download the PDF copy. Okay. You can follow up me with this social media. This is my YouTube channel details. And like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. And if anyone wants to prepare with the government job, you can go through me another YouTube channel, government job with Laxmikanta. You can also follow up this channel. Okay, so that's it for today. We'll meet in the next video as soon as possible. Thank you.